Hi, in this tutorial I'm going to show you how to create a custom Spur gear generator, making it as robust as Shapr3D constraints will allow. So let's get started. If you're in a hurry and just need to create a gear right now, don't worry, I got you covered. You can head over to my GitHub, link in the description down below, and clone the repository. Open it in VS Code, make sure you have Python and the required libraries installed, and simply change the module, number of teeth, and pressure angle to fit your needs. Run the script and it will generate a perfectly scaled DXF file. Finally, just drag and drop into Shapr3D, hit extrude, and you're ready to go. This Python script is just a beta. I'm currently working on a much more user-friendly version with a full interface and even more advanced features. So keep an eye on the repository for future updates. Okay, to create our gear generator in Shapr3D, we will need inputs. The first one is the module M, the number of teeth Z, and the pressure angle alpha. With those, we will trace the root circle, the base circle, the pitch circle, and the tip circle or addendum circle. Then, using the involute function, we will calculate the exact coordinates to plot the tooth flank, the root, then mirror around the x-axis, and finally a circular pattern to complete the gear profile. Okay, let's start by creating our variables. Insert, variable. Let's start with the inputs. M. Let's add a placeholder of 2. Now let's go to the number of teeth, Z, and a placeholder of 20. Now a pressure angle alpha, 20 degrees. Okay, I will continue with all the variables and get back when finished. This Shapr3D template file will be available on the link in the description down below, so you don't need to do it manually. But also I'll share with you the sheet with all the formulas and equations used on this template. Here we have our template with all the variables defined, the inputs at the top. I have added also a variable for the thickness of the gear, but the variable I want to discuss briefly, it's a variable called rstart. For small pinions, the root valley actually dips below the base circle, where the involute curve mathematically cannot exist. This line simply stops the curve at the base circle, making our code bulletproof for any gear size. Okay, let's draw the base circles. Let's start with the pitch circle, which is 2 times r. Now draw another circle, 2 times rb. Let's make constructive both. Another circle, 2 times ra. Now let's draw rf, which is the root circle, 2 times rf. And finally, let's draw the start circle, which will define the start of the involute, 2 times r start. And okay. Let's change this circle to constructive. Great. Now we have our base circles. This involute is calculated with 4 points. For the sake of simplicity and visual clarity, I will use only point 1 and 4, and the middle point will be placed at the pitch circle at an angle phi. This defines the tooth thickness exactly where the gears make contact. As an exercise, you can use 4 points or more if you want more precision, and use a spline instead of a 3-point arc. Okay, let's now approximate the involute. Let's trace a line. Will be constructive. The distance between this point and this horizontal axis will be y1, Okay. Now this one will be Y4. It's here. Okay. Now let's go with the X coordinates. This one, X1. And finally this one, X4. Great. Now let's go with the middle point. This trick is pretty simple. Just draw a line, finish it on the pitch circle, and add an angle phi, which is 4.5. And that point is exactly the contact point. Great. Let's create an arc. First point 1, point 4. Okay. And now we will make coincident with the contact point. And now we have approximated the involute with these 3 points. To connect the root, draw a line until the root circle. Make tangent relation between the curve and the line. And that's it. Now let's make sure that this line will not move. So let's draw a line from the center and connect it to this point and make it constructive. Great. Now we have a fully defined sketch. Now let's mirror the flank and root. Select these lines and the horizontal axis. Go to more, mirror, and done. Okay, let's now close the sketch. Let's select the tooth profile. And let's extrude. Drag the arrow. This will be thickness. And hit OK. Great. Okay, next thing is to create the circular pattern. So double tap, go to pattern, move the control origin. This one will be Z, number of teeth, and 360 degrees. Okay. Now go to items, activate the sketch, select the root circle, and extrude also thickness. Okay, now my recommendation before merging the bodies is to define first the gear you want to create, and once it's defined, then you can merge the bodies. Otherwise, you will have some issues. Now it's time to test our gear generator. Now we can relax and just change values. For example, let's change to 25. Done, no problem. Change the module to 1. Okay, everything works fine. Let's go back to 2. What about 19? Works fine. 30. Okay. Let's go back to 20. Okay, now let's suppose that this is the one I want. So we can merge now. Select the circular pattern and done. Now we can apply the root fillet. So let's select all these edges. And the fillet will be also a variable. So let's choose root fillet and done. Great. So now we have our gear. I will do a quick assembly test so you can check that everything is okay. And yeah, the contact point is in the correct position. So everything is good. Finally, you can add all the details you want to complete the gear, and that's it. As a final note, if you are actually going to 3D print this, our script already calculates the vertical clearance, but to prevent the gears from jamming, we need horizontal breathing room, known as backlash. Okay, let's go to the first extrusion feature and insert a breakpoint. Now we can add an offset, so let's select these faces. And the offset will be minus 0.1, and okay. We can also create a variable for this offset, so we can go to insert, variable. Okay, it will be print clearance, it's okay. And 0.1. Okay. Okay, let's move it to the top. Great. And let's replace the offset value by this one. Print clearance. Okay. Now let's remove the breakpoint. Tab, delete. And let's change the value to the correct one, which is minus 0.1. And now you can adjust this according to your needs. So if I change the value again, let's say 0.2, negative, it updates correctly. Great. Thanks for watching.